Okay, Year 11. Let's talk about these big words, oxidation and reduction. So, if a metal loses electrons, they've got to go somewhere. There must be another chemical species around that's gaining electrons, okay? Reactions that involve the transfer of electrons are known as sometimes electron transfer reactions. You may hear that term occasionally, but more commonly, redox, okay? Short for reduction oxidation reactions, okay? When something loses or donates electrons, we say it's being oxidized, okay? Because commonly, metals lose electrons in the presence of oxygen. That's why it got its name. When something does the opposite, it gains electrons, we're saying it's being reduced, okay? How I remember that is link it to the charge being reduced, okay? Reduction and oxidation happen in pairs. This is very important. Always together, okay? You can't just spontaneously lose electrons. Something must be gaining them. So therefore, they never happen by themselves. They happen as a redox reaction. Something is oxidizing, something is reducing. Okay. Oxidation means loss of electrons. So something that's being oxidized will gain charge then. Here in my example, I've got copper going to copper 2 plus. Okay. Here initially the charge is 0, then it increases to plus 2. 2 electrons were transferred. 2 electrons went somewhere. So it lost electrons. So here copper is being oxidized. It's going from 0 charge up to 2 plus charge. Okay. Reduction means gain of electrons. Okay. Here I've got iron 2 plus going to iron solid. It has gained 2 electrons, so it has been reduced. Iron has been reduced here because it had 0, or it stayed at 2 positive, and now it's got 2 electrons, it's being reduced. Okay. One common way to remember this is this oil rig thing here. Oxidation is loss, reduction is gain in electrons. Okay. May help you out there. So let's revisit this one from a couple of videos ago. We had copper in a beaker, copper wire, and we put silver nitrate in there, or silver plus, and we saw a displacement reaction happen. So we had silver plus going to silver, and we had copper solid going into solution of copper 2 plus. I know you can't see that too well, okay? So we had copper going to copper 2 plus. So it was losing electrons, so it was oxidized, and silver was going from silver plus to silver solid. It was coating it, it must have been reduced. So this displacement reaction was a redox reaction. We had silver being reduced while copper was being oxidized. Okay, so going back to our old terminology too from the earlier video, silver liked electrons and had a stronger attraction to electrons than copper. Copper lost its electrons, silver won out in that tug of war. Okay, when displacement reactions take place between a solid metal and a solution, redox reactions take place in all states with non-metals involved. Okay, so what I'm trying to say here, I don't think I've done it that successfully. Previously, we've talked about metals here, okay? It happens with metals and displacement, but redox reactions are much wider. They don't necessarily have to happen with metals as well, and we can apply this knowledge to past chemistry that we've done, okay? And here I've done it with magnesium and oxygen, or the combustion of magnesium to form magnesium oxide. It's actually a redox equation. We can split it into 2 halves, the magnesium and the oxygen. The magnesium initially is just solid magnesium, and it's going in magnesium oxide. Even though it's not in solution, it's going to magnesium 2 plus. So it must have lost 2 electrons, or it must have been oxidized, okay? Oxygen is going to oxide, okay? So it must have, with O2, lost 4 electrons. So it has gained 2 electrons, so it is being reduced, okay? And the opposite partners have caused that. So magnesium's being oxidized, but it's being oxidized by the oxygen. Weird. Oxygen is being reduced, but it has been done that by the magnesium words. Okay, so we had a net transfer of electron, one loses and one gains, therefore it's just a redox reaction too. So we can call it a combustion reaction, and most times that's what we'll call it, but recognize that it's also a redox reaction. Oh, I haven't got any lovely diagrams here. Anyway, the reaction of a metal and an acid is also a redox reaction. Here I've got an example of zinc and hydrochloric acid. So break it in half. Oh, which I've done. I've done it all together, zinc and H+. Remember H+ is an acid. So we've got zinc going to zinc 2+. So it's given up 2 electrons. And we've got the acid, 2 acids there, and 2 electrons going to the hydrogen gas there. Okay, so zinc loses 2 electrons to become zinc 2+, so it must be oxidized by the hydrogen ions or by the acid. So 2 hydrogen ions gain 1 electron each to become 2H2+. Why am I saying plus? 2 hydrogen ions gain 1 electron to become H2 or hydrogen gas. So therefore H+ is being reduced, and it's being reduced by the zinc. They work in partnership. Okay. New words, and this is quite confusing. It's language. Okay. Redox reactions happen with a reduction and an oxidation. Okay. They happen in partnership. In redox, you'll notice one is being oxidized and one is being reduced. The one that is being oxidized has been oxidized by the partner, and the one that's being reduced has been reduced by the partner. Okay? An oxidant or an oxidizing agent is the one that's doing the oxidizing. It isn't what's oxidized though. So let me just read this word for word because I think it might be better. An oxidant or an oxidizing agent is the substance that brings about the oxidation. It is the substance that is being reduced. Opposite. A reductant or the reducing agent is the substance that brings about the reduction of the other substance, and it itself is being oxidized. Okay, so the species that is oxidized must have in partner caused the reduction, and is also known as the reductant or the reducing agent. The species that is reduced must have caused the oxidation, must have caused the partner to happen, and so it's known as the oxidant or oxidizing agent. Okay, let's do some examples here. Iron reacts in the presence of oxygen to form iron 3 oxide. Give a full chemical equation. Okay, iron, presence of oxygen, O2 gas, iron 3 oxide. Fe2O3 solid. Okay. Are we balanced? 2, hang on. I'm going to put a 2 there. And therefore I need a 4 in front of the iron. And so we've got 6 oxygen, so I need a 3 there. So there's my full balanced chemical equation. The 2 half equations, let's pull them out. We've got iron solid going to iron 3 plus solid. I know that's a bit weird seeing a solid by itself, plus 3 electrons. Okay, must have given up 3 electrons. O2 is going to oxide, and so it must have gained 2 electrons. I know that's not balanced. Okay, we'll do that later. Which chemical species is being oxidized and which being reduced? Okay, so iron is going from 0 to 3 plus. It's losing electrons. It's losing the 3 electrons. So iron is being oxidized, and oxygen is being reduced. So I've identified what's being reduced and what's being oxidized. Why don't I change this question to what is the oxidant and what is the reductant? I think I was just looking at the next question for that. So therefore, I'm going to add it in there. If iron is being oxidized, it's causing the reduction in its partner. So it's the reductant or the reducing agent. Should I write that next? Okay, oxygen is being reduced, so it's causing the oxidation. So it is the oxidant or the oxidizing agent. Alright, let's look at the next example. Write the chemical equation for the reaction between aluminium and sulfuric acid. Aluminium, H2SO4. We're forming, we've got an acid and a metal, so we're forming hydrogen gas and the salt. What is the salt? The sulfate of the sulfuric acid that's left over in the aluminium. Aluminium has a charge of 3+ when it's as an ion. So it's going to be Al2, and we need 3 sulfates. That will be in solution because we had a solution for the sulfuric acid. So we need 2 aluminiums and we need 3 sulfates. And so we've got 6 H's, so we're producing 3 molecules of hydrogen. The relevant half equations, nice and simple. Aluminium is going to aluminium 3+, and 3 electrons have to be given up. So it's losing electrons. And the H+ in the acid is going to H2. So we need 1 electron there, okay? Haven't balanced them out. You can do that yourself. They're the 2 relevant half equations though. Which chemical species is being reduced and which is being oxidized, and I'm going to add in what is the oxidant and what is the reductant. Okay, so aluminium is giving up electrons, so aluminium is oxidized and H+ is reduced. It's gained electrons. So aluminium has caused the reduction in H+, so it's the reductant. H+ has caused the oxidation of aluminium, so it's the oxidant. Okay, you got enough knowledge to do this identifying redox reactions. Okay, thanks guys. Talk to you soon.